Okay, some of you may have done this type of question with me last year. So in this case, we have a boat that wants to cross a river directly to the opposite side. So we have the velocity of the boat relative to the water. So BW, velocity of the boat relative to the shore, velocity of the water relative to the shore. So in setting up the scenario, you get the following. So I can say, here's my river. I say the stream is traveling in this direction. Here's my stream. And our goal is to get directly across the river. So we says, how do we get directly across the river? So I'm going to draw my resultant vector first. My resultant vector is going to go directly across the river because that's where I'm going to go. I want to have some starting point and I want to end over here. My finish line. So how do I get to start to finish? In this case, we have two vectors. So first, the boat has some speed. If there was no stream, the boat would be very easily just go straight across, like if it's on a still lake. However, because the water is flowing to the left, based on how I drew it, we have two vectors that, when we add them together, the velocity from the boat plus the velocity from the water has to end up at our finish line. So we already know our stream, so I can actually draw that in first. So I know that using tip to tail method, my two vectors drawn tip to tail, let's go from start to finish. So my stream, so one way I can do it is the following. So the stream is to the left, so here's the stream. Let's do that with a different color. So here is the stream, for example. Stream is going left. So the only way for our boat to get to the finish is actually to angle ourselves slightly against the stream, like the following. So this would be the velocity of the water relative to the shore. This is the velocity of the boat relative to the shore, or to the water. Again, it doesn't matter if I do v1 plus v2 or v2 plus v1. I could draw the boat first, and then I can draw the water vector. Notice how they still get to the finish line. So again, this is our velocity of the boat relative to the water. And this is our velocity of the water relative to the shore. And this is our velocity of the boat relative to the shore. Let's make sure we understand what these mean. So from the water's perspective, it's seeing the boat heading into it. Like that, the boat is angling towards the water. This is from the shore's perspective right here. If you were some person standing on the shore watching, you just see the water flowing to the left. This is VBS. So even though the boat is angled and pointing in this direction against the stream, what we observe is because when we add those two vectors together, the boat itself will simply travel from start to finish. So a person on the shore will observe the boat just going straight across. Now, usually when we compare the speeds of boats and streams, the boat speed is way faster, or the airplane speed is way faster than the water or the air in question. But for lots of these questions, we will really exaggerate it. So what we can kind of picture it as, like if the boat was just facing directly across the river, and that stream was going to the left, that boat will end up off course because, of course, the water is just pushing it away. However, because in this case the boat is angled against the river and the water is traveling left, it's pointing this direction, but it's actually going to travel straight up. So the boat is going to actually be angled in the direction it's facing, but it's going to travel straight across that river.